Okay, we have talked about this before, but just to be entirely clear, if you're asked if a function or a relation or something, graph, where is it positive and where is it negative? That's different from where is it increasing, where is it decreasing. It's not like is the slope of the tangent positive or negative. It's where is the function positive or negative. That's just asking is it above the x-axis or below the x-axis, right? Very simply, but I think, make sure we're clear about that. That's what you're being asked if a function is positive. So in other words, is y positive? The y value of a point on the function in that location, is it positive, the y value positive, or is the y value negative? Okay, so that's what it's asking. So here's a question for you. What properties of a function might allow it, maybe it does, maybe it doesn't, like might, maybe does, maybe doesn't, okay? Allow it to change from being negative to positive or vice versa. Think about that for a minute while I answer the phone. Still there? Yep. Drummer room, yes. Okay. Sam, drummer room? Yeah. Yeah, I think it was Mr. Klein. Okay, so what do you think? Under what circumstances or what properties? Just name one. There could be several. Name me one.
A turning point?
A turning point. That would allow it to change increasing to decreasing, but that's not what we're talking about. We're talking about positive to negative. X-intercepts, that's one of them, right? So an X-intercept, let's sketch some crazy function here. What's going on? So where is it negative? It's negative here, and it's positive here and here. So X-intercepts is 1. What's another property of a function or circumstance where a function might change from being positive to negative? Think about what we've been doing lately. An asymptote. So Brandon said crossing over an asymptote. So if I draw in an asymptote, and I draw some random function, positive, and then all of a sudden cross the asymptote, negative. Now this one happened to cross back over, just because I was scribbling it, but like it crossed back, but for a while, right? Here it's negative, and then positive and positive. So specifically a vertical asymptote. Anything else? What other kinds of things have we? I suppose a horizontal asymptote, not exactly. Like a horizontal asymptote at 0 means there wouldn't be an x-intercept, and it would cross without touching, kind of like that did, but there would have to be something else going on there. So horizontal asymptote might kind of have something to do with it, but not really one of the things we're looking for. There's one more that could happen. What's the other kind of thing we see? Like we've seen this unit. What other new thing? Oblique asymptote? Yeah, sure, could, absolutely. We don't know how to find those, but yeah. What else? It's really small. Thomas? A hole! So if I have a hole in the function, like if it's coming up, and it would kind of be like an x-intercept, but it's not because there's a hole there. This happens maybe rarely, but it's something we need to account for, okay? So usually holes, I don't know, usually aren't right on the x-axis, but it's something we need to think about. Does that make sense? So those are the circumstances under which a graph could be in the positives or in the negatives and then change. Okay? It was below the x-axis, now it's above, or vice versa. Okay, so we are going to solve inequalities. How do we do this? Take a look at A. What's it asking? When is this bigger than 0? Which means we also will know when is it less than 0. So in other words, an inequality like this, and the other ones we were looking at as well, we just didn't think of it that way because we didn't have to. When is it greater than 0? When is it less than 0? When is it above the x-axis? When is it below? Right? That's what this is asking. So what we can do is we can find all of those values, which we already know how to do. You already know how to find vertical asymptotes and holes and x-intercepts. You already know how to do that? So we do that, and then we just test to see if it's positive or negative between those intervals. Does that make sense? Happy with that? Why can't we just solve this like we were doing yesterday? Well, if I multiply both sides by x plus 2, first of all, you end up with something nonsensical in this case, because you get x on both. Well, you don't get x on both sides. No, you would get a solution, but the bigger problem is sometimes you could get something nonsensical. But the bigger problem is, what if x was -5? That means I'd be multiplying both sides by a negative, because this bottom would be -3. And what do you do with an inequality when you multiply both sides by a negative? You change the sign, right? You reverse it. So if I multiply both sides by x plus 2, I wouldn't know if I'd be required to change the sign or not. So you could, I think, like, do that, but you'd have to do both, and then you'd have to like run a check to see which one's actually right. Like you'd solve to get an answer. So you get an answer of 3, and then you check, well, is it bigger than 3 or -3? Like it would be a messy process. So that's not how we do it. So this is how we do it. This one's already pretty much done for us. We don't have to do any extra work. We're just going to state the vertical asymptote, which is x equals -2. Right? That comes from the denominator. When the denominator is 0, look back in the notes a couple days, but when the denominator is 0 is when you get a vertical asymptote. So that's the only one. And when do we get an x-intercept? This has come up, and this is something that you know, although I don't know if we've talked about it explicitly. There's an easy way in rational expressions, rational functions, to determine an x-intercept when the top is 0. Right? When the top is 0, when the numerator is 0, the whole, unless there's a hole, the whole function is 0. Doesn't matter what's on the bottom. Top is 0, the whole thing's 0. So an x-intercept in this case occurs at +3. Does that make sense? If I put 3 in there, I get 0/5, so that's 0. So the whole function 0, that's what an x-intercept is. Okay, so we're going to draw our number line like we did with other inequalities. And we're going to put a vertical asymptote at -2. Notice how I actually draw it as a vertical asymptote. That's a good trick. You'll find out why later on. And then 2. And then I have to check values within all 3 of those intervals. Okay, so I'm going to pick a really big negative number, and that would be something like 10, a -10. So the top's negative, the bottom's negative, so the whole function, I've got two negatives divided, so the whole function's positive. Cross over the asymptote. Let's pick 0. I like to pick 0 when it's an option. Makes the math easy. That's negative 3 over positive 2, so that's a negative. And then pick a big positive number, 10. Both positive, so I'm back to positive again. If you ever ask yourself, does it matter what number I pick? Like I always pick 10, or you can pick 100 if you want, so I don't have to actually do any math. I just think about the sign of each factor. And if you ever matter like, well, 10's really big. What if I only picked 4? Would that change it? No, because of how we've set, as long as you set up your intervals properly, which you kind of have to, if you don't, the whole thing's going to fall apart. As long as you set up your intervals accurately, it won't matter what value in the interval you pick. And so big values, or values like 0 make it easy. So we were wondering when this expression is greater than 0. So it turns out when x is less than negative 2 and when x is greater than 3. X minus 3, x plus 2. Let's check this thing. See what it looks like. X minus 3, x plus 2. So it's above, so it's positive, and then we hit that asymptote at negative 2, and it goes to below, and then look at that, crosses the x-axis at 3, and it's above again, and it's above forever, under the horizontal asymptote, but always will be above, always will be positive. All right, let's try another one. So why don't you take a crack at this one, find the vertical, it's going to be basically the same, just going to have some fractions. Find the vertical asymptote, find the x-intercept. There's only one of each. And come up with your intervals to test. Again, make sure you draw these in order. Like start with the smallest one and then end with the biggest one. Write them in the right order. You have to write them in the right order, obviously, but even if you flipped it and did the big ones first, you're going to confuse yourself, especially if you start graphing these as well and doing different things or thinking about intervals of increase and decrease. If you've got your line drawn backwards, you're going to confuse the heck out of yourself. So make sure you draw them in the right order. Like I said, I always do a little asymptote there. And then for an x-intercept, just show it as an x-intercept. So if I pick a big negative number like negative 10, 2 times negative 10 is negative 20 minus more negative, so the top's going to be negative, and the bottom's going to be something big negative plus something small, so that's going to be negative, so it's going to be positive. What if I pick zeros in that one? There's a few questions in the practice that has nasty fractions. It's a bit of a pain in the butt, but this one's fine because there's zeros in this interval. So 0 minus 5 and 0 plus 4, that's going to give me negative. And then a big number after 2.5 is going to give me all positives. So kind of the same. But this question was asking when is it lower than 0? So let's use interval notation. So it's lower than 0 between negative 4 over 3 and 5 over 2. Right, same thing. Any questions? All right, let's keep going. What do we have to do for this one? Factor it. So I got vertical asymptotes at x equals 8 and x equals negative 3, and x-intercepts at negative 4 and negative 2. All right, so we'll start at negative 4, which is an x-intercept. Then I've got negative 3, which is an asymptote. Then I've got negative 2, which is an x-intercept. And then I've got 8, which is an asymptote. Lots of intervals to check here. Something big and negative. First factor on top is going to be negative. Second factor on top is going to be negative. Factor on the bottom is negative. Factor on the bottom is negative. So 4 negatives makes positive. I'll check negative 3.5. So negative 3.5, this first bracket here, x plus 4, will be positive, right? Because 4 is bigger than negative 3.5, so it's going to win, and this whole bracket is going to be positive. But then negative, negative, and negative. So 3 negatives means the final outcome's negative. Let's pick negative 2.5, so I'm going to get 2 negatives on top. No, sorry. Yeah, that first one's positive. Sorry. Positive and negative on top. That's right. Positive, negative, and then negative and positive again. So 2 negatives, 2 positives, so overall positive. Now I can pick 0, and that one's going to be negative because of the negative 8. And then pick a big positive number like 100. Positive 100 plus any of those things is going to be positive, so positive. Is that okay so far? Now here's where it's important to think about asymptote compared to x-intercept. Where is it greater than or equal to 0? So it's greater than 0 up to negative 4 and equal to 0 at negative 4, right? So let's say we're going to do interval notation from negative infinity to negative 4 inclusive. And then from negative 3 to negative 2, it's also positive. But how do my brackets look? It doesn't include the asymptote because it never equals that. So that's a round bracket. But negative 2 is an intercept. It does equal that, so it'll equal 0 at that point. It will not equal 0 ever at negative 3, but it'll be greater than 0 after that. Does that make sense? So if you think about asymptote compared to x-intercept, then you know inclusive or exclusive. And then there's one more, and again, it's at 8, which is exclusive because it's an asymptote. And infinity is obviously always exclusive as well. Good? Any questions? Okay, let's factor the next one. Go ahead. It's pretty easy. So we've got an x-intercept at negative 4 and a hole at positive 4. No vertical asymptote. So what does this one look like? X-intercept at negative 4. Unless it's a turning point x-intercept, we know that it's going to change from positive to negative there, right? Like that's what an intercept is. We know that there are turning point x-intercepts where it doesn't. We know what they look like, so you can kind of cheat and think about that. And then 4, and I'm going to mark it as like a hole. Like just put a circle so I know that what kind of thing that is, so that I can interpret my answer and make sense of it. So looking at this factored form, if I put in negative 10, then I get everything negative. So it's negative. If I put in 0, I get positive. And if I put in like something big after 4, like 10, I still get positive. So very often with holes, you don't see a change. It's just out in the middle of nowhere. But you could. Okay, you certainly could see a change. So we got to be careful. So let's see, this was greater than or equal to 0 again. So it's greater than or equal to 0 when x is greater than or equal to negative 4. Wait. Yes. As long as x doesn't equal 4, because it's not true. So actually, I'm going to rewrite that. So from negative 4 is less than or equal to x is less than 4, and then x greater than 4. That's the better way to show that it doesn't include 4. Because it doesn't exist at 4. We can't just ignore that. We don't just ignore that. We include that in our answer. Everybody still good? All right, we'll keep going. So in this case, if I multiply both sides by x plus 2, I'd get x plus 3 equals x plus 2. Then the x's would be gone and I'd get 3 equals 2, or greater than 2, which is true. 3 is greater than 2. But that's not helpful, right? That's not how we solve this. So again, this isn't the same as solving. It's not like what we were doing yesterday where we're clearing fractions. We're looking for the factors. We're looking for the asymptotes and the x-intercepts and that sort of thing. So what am I going to do? I'm going to multiply both sides by, or I'm going to multiply, by a common denominator. I'm going to get things into a common denominator. So the x plus 3 is fine. I'm going to take the 1 over and I'm going to subtract it. And I'm going to multiply by x plus 2 over x plus 2. Right? So it's kind of like 1 over 1 times x plus 2 over x plus 2. This is like we're getting a common denominator. So now I have x plus 3 minus x plus 2 over x plus 2 greater than 0. So now I'm going to simplify the top. X minus x is 0. 3 minus 2 is 1. So I get 1 over x plus 2 is greater than or equal to 0. And I get just a vertical asymptote at x equals negative 2. And so before negative 2, it's negative. After negative 2, it's positive. And so my solution is when x is greater than negative 2. Yeah. Because there weren't any. Like if you try, like this one's a little bit different because it's got it's greater than or equal to 1, so it's a little bit different. But if you graphed, like if you simplified it and graphed it, you'd see that it just doesn't have any x-intercepts. So we're going to run out of time here, looks like, but I have a few examples left, but that's okay. So Ross, to finish your question, like it's 1 over x plus 2, 1 can never be 0, so it doesn't have any x-intercepts. Okay, so I had a few others, but they're kind of similar. Let's do one more, if we can fit it in. Or I'll just get us started, actually. I'll just show you what this kind of looks like. I need a common denominator, so I got to multiply. So I would have to multiply the first one by, I'll finish it and put it up on the classroom, but I'd have to multiply the first one by x minus 3 over x minus 3, and the second one by x plus 2 over x plus 2 to get a common denominator, actually subtract, simplify everything. If you have to factor so that you can look for x-intercepts and such, and then finish it off by interpreting your answer. Okay, we're going to finish this lesson on solving rational inequalities. So for this next one, I'm going to move the 2 over. And I have to multiply the top and bottom by x plus 3. So that's going to look like 2x plus 3 over x plus 3. Greater than or equal to 0. I've got common denominator. So I can get 2x minus 1 minus 2x plus 6 over x plus 3. 2x minus 2x, that's going to be gone. And negative 1 minus 6 is negative 7 over x plus 3 greater than or equal to 0. So again, I just get one vertical
asymptote at x equals -3 and -3. And if, let's see, if x is negative, like -10, then the bottom's negative and the top's negative, so it's positive. And if I make it a big number, then it's negative over positive, so it's negative. And x is greater than or equal to 0, but this is an asymptote, so it won't equal 0. So then my answer is going to be -infinity to -3. Exclusive. Okay, two more. So I'm going to have to factor the top and the bottom. Actually, I won't factor the top yet. I got to simplify that before I factor. There's no reason to factor yet. So I'm going to start like this. I will factor the bottom. Let's see, x plus 6, x minus 3, minus, and then this little trick, I want the top simplified, but the bottom factored, right? That's just what I want for the next step. So this guy right here is 1. It's the same expression over the same expression, just simplified and then factored. And so I move the 1 over, subtracted 1. And now I have what I want on the bottom and I have what I want on top. So I'm going to get 2x squared minus x squared, which is x squared. Negative x minus 3x, which is negative 4x. And negative 1 minus negative 18 is plus 17 over x plus 6, x minus 3, greater than 0. So the top's not factorable. It would be, a bit of a pain, I guess, to use the quadratic formula here. But if you had to, you'd have to. You'd get some rounded answers and just use that as your interval and then, check between the intervals. That wouldn't still be so bad. But it turns out that if you do b squared minus 4ac, in this case, it is less than 0. So there's no solution to that top part. So I did check that. You absolutely need to check that. And then I have two vertical asymptotes, one at -6, one at 3. So -6 and 3. And when I do the check for this, I'm going to get, so let's take -10 for example. -10 squared is positive, and then times a negative is positive, and a positive, so the top is positive. And then I've got two negatives on bottom, so it looks like I have two negatives and a positive, so that's going to be positive. I'll check 0, so 0 gives me 17 on top, and it gives me a positive and a negative, so that's negative. And then if I check a big number, like let's say 10, now this one, let's see, or let's make it 100. That's going to make this really big and positive, and this is kind of big and negative, and this is big and positive, but overall the x squared is going to win out, right? So 100 squared, big number, minus 400 plus 17, still positive, and then that's positive and that's positive. Everything's positive, so I can just use a little bit of logic there and make sure I figured that out. And so therefore this is greater than 0, so my answer here is it's greater than 0 for x less than -6 and for x greater than 3. That's my solution there. And the last one, I've got two denominators. A little bit more work here. So I'm going to get a common denominator between these two. So the first one, if I'm going to show my work here, x plus 2, I'm going to multiply it by x minus 3 over x minus 3, and then subtract 2 over x minus 3. I'm going to multiply this one by x plus 2 over x plus 2 less than or equal to 0. So I get x minus 3 minus 2 times x minus 2 is 2x plus 4 over x plus 2, x minus 3, my common denominator. Okay, And so that's going to be less than or equal to 0. So that's x minus 3 minus 2x minus 4 over my denominator. X minus 2x is negative x. 3x minus 4x is minus 7. And so here's a little trick. I mentioned this before. It's too bad we didn't get to this in class. When I start thinking about what's negative, what's positive, and plugging negatives in, it can be a little bit more taxing on your brain when you've got all these negatives on top. So what if I factor out a negative? So this is just a trick that sometimes you might want to use. And then what I'm actually going to do is I'm going to multiply both sides by a negative. What happens when we multiply both sides by a negative? X plus 2, x minus 3. I got to flip the sign. Right? So now I'm solving something a little bit different. Okay, so let's look at this. So, oops, I've got my vertical asymptotes at x equals negative 2 and x equals 3. And I've got an x-intercept at negative 7. Okay, so negative 7 is an x-intercept. Negative 2 is an asymptote. And 3 is an asymptote. So negative 10. So that's negative, that's negative, that's negative. 3 negatives is negative. Let's say negative 5. That's positive, negative, negative. 2 negatives and a positive is positive. 0, positive, positive, negative. And 10, positive, positive, positive. So here we go. And now it's greater than or equal to 0. If you had done this with the negatives from this line up here, you would have got the same answers for sure. It just would have looked a little bit different with your number line. And so let's see. My answers are... and this is a great one to interpret as well, because this is going to include negative 7, but not negative 2. And it will not include 3, or obviously infinity. Right? And that's those last 3 examples.